Hi, fourth grade. Today we are looking at lesson 11, day 5. We are on page 124. We'll be working on pages 124 and 125. This is day 5. So remember, this is where you do the problems independently and then you check your answers. This is what we would do if we were in class. So you can do a few things. You can go and do pages 124, 125, and then come back and go over your answers with me. Or if you want to do number 1, see what I get for number 1, do number 2, see what I get for number 2, or do it along with me if you're confused. Just a few options for when we do multiplication. Remember, you can use area models. That's where we decompose the problems or the factors into the expanded form and put them into the boxes. Or you can use partial products, where we find partial products to each of the multiplication equations, and then we add our products up to get our answer. So both great strategies. When in doubt, you can double check with repeated addition and number line, some of those other strategies we used as well. And just don't forget that you might be estimating sometimes as well when it comes to lesson 11. You just have to be wary of some of the wording when it comes to the question. So if you look at this first one, on average, a person blinks 16 times per minute. How many times does a person blink in 3 hours? Hint, 1 hour is 60 minutes. So we want to highlight that a person blinks 16 times per minute, and that how many times does a person blink in 3 hours? And when we go to solve this, we don't want to forget that little hint that they have there for us, that 1 hour is 60 minutes. So I am going to, for this problem, in my mind, I know I need to do 3 hours. So I want to figure out how many total minutes there are in 3 hours. So in order to do that, I'm going to do the easy multiplication problem of 3 times 60, because there's 60 minutes in 1 hour and I want to know how many minutes for 3 hours. Well, 3 times 6 is 18, and then I have to add 1 0 because there's 1 0 in one of my factors. So there's 180 total minutes that I'm solving for. So I had to do that first. You could have also taken 16 times 60 and then taken that answer times 3. That would have worked as well. So this is just how I'm going to look at it. So then I need to take that 180 minutes and I need to multiply that by 16, because 16 times per minute we blink. And as I'm saying this, I'm thinking about how many times I'm blinking because I'm self-conscious about it now. Okay, so we have 180 times 16. Okay, so if we start with the ones, we've got 6 times 0, which is 0. 6 times 80, put my 0 in, and then 6 times 8 is 48. And lastly, 6 times 100, put my 2 zeros in, and then 6 times 1 is 6. All right, let's go to my tens place. So 10 times 0 is 0. 10 times 80, put my 2 zeros in, and then put my 8 in. And then lastly, 10 times 100, put my 1, 2, 3 zeros in, and then 1 times 1 is 1. And then I have to add those all up. So zeros in that first column, give me 0. 8 plus zeros, give me 8. 6 plus 4 is 10. 10 plus 8 is 18. So I've got 8, carry my 1. 1 plus 1 is 2. So 2,880 total minutes, which is going to be answer D for number 1. You could have also used partial products, you could have also used an area model there as well. Okay, let's look at number 2. Mr. Larson is planning a pizza party for 273 people. He plans on 3 slices of pizza for each person. How many slices is this in all? So a pizza party for 273 people, 3 slices of pizza per each person. And then how many slices of that is that in all? So here we're doing 273 times 3 pieces per person. I'm again going to use partial products. So 3 times 3 is 9. 3 times 70, put my 0 in. 3 times 7 is 21. And then lastly, 3 times 200, put my zeros in. 3 times 2 is 6. So when I add it up, I get 9 in my ones column. 1 plus 0 is 1. And then 6 plus 2 is 8. So I have 819 pieces of pizza for that pizza party. That's a lot of pizza. Okay, number 3. So this one's a little different. They want to know, can the expression, which of these expressions, I guess I should say, could be used to solve 29 times 14? Choose yes or no. So for A, if we were to do partial products, I'm just going to kind of do it on the side here so you can see it. 29 times 14, I would have to do 4 times 9, 4 times 20, 10 times 9, and 10 times 20 to get my answer, right? Here we go. It's a little bit better. Those would be all the different equations that I would do. So if we look at A, okay, 9 times 4 I have to do, 20 times 4 I have to do. Okay, and then this is where it kind of gets blurry, where I say I don't have to do 9 times 1. So that one's a no. Okay, if I look at the second one, 14 times 9 and 14 plus 14 times 20. Well, if I decompose the number 20, I can get 20 plus 9. That equals 29, right? So I could do 20 times 14 plus 20 times 9 to get my answer. That one's going to work. All right, let's look at C. All right, we've got partial products. 4 times 9, 20 times 4, 9 times 10, 20 times 10. That hits all of my partial products. That's a yes. And lastly, 29 times 4 plus 29 times 10. So same thing, like we decompose 29, we can decompose 14 to 10 plus 4 equals 14. So we could do 10 times 29 plus 10 times 4. Oh, I'm sorry. 10 times 29 and 4 times 29. That would be yes for that last one. Okay, let's go to page 125. All right, for number 4, which models below could represent the solution to the problem 45 times 15? There are 2 answers here. Okay, so we're looking at 45 times 15. So if we look at A, okay, A is decomposing 40 into 40 and 5 and 15 into 10 and 5. Those are both options. 40 plus 5 is 45 and 10 plus 5 is 15. And then it shows an area model, but it just shows the actual area filled in. So that would work. A is a possibility. B, they're showing a number line. They have the number line going by 15 and they have it stopping at 45. So in this case, this would not work because it's only showing 15 times 3. It's showing 15 as the skip counting and it's only going 3 spots as opposed to going 45 spots or 15 spots depending on your number. C, if I were to break this problem down into partial products and do 45 times 15, right, I would have 5 times 5. I would have 5 times 40. I would have 10 times 5, and I would have 10 times 40. So let's see if they have those. 4 times 1, no. 4 times 5, no. 5 times 1, nope. 5 times 5, nope. They don't have any of my partial products in there, so not C. Let's look at D. So D just has 4 times 1 plus 5 times 5. So no matter how we decompose those numbers, we won't decompose them that way, and those aren't any of my partial products, so it's not going to be D. If we look at E, E is skip counting by 45s. Okay, well, that's the right number. Let's see how many times they've counted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So they've skip counted 45 15 times, so that would work. All right, let's look at 5. Mo had 8 tutoring sessions. Each session was 35 minutes long. About how many minutes did Mo spend in those 8 sessions? So each session was 35 minutes long. He had 8 of those sessions. About how many minutes did Mo spend in the 8 sessions? What's really important to point out here, it says about, so we're estimating. Please, please, please keep that in mind when we do our lesson quizzes and when you move forward. That about is a signal that you're estimating. You do not want to find the exact answer. If you find the exact answer, it's going to be marked wrong. They want an estimate. So I'm going to round, keep 8 as 8. I'm going to round 35 to 30. So if I do 8 times 30, 8 times 3 is 24, and I have a 0. That's one option. You could also look at it as, well, there's actually quite a few different things. You could do 10 times 35 to give you 350. As long as it's reasonable and you have a good explanation as to why you did what you did, that's great. So about how many minutes, this answer could vary based off how you did your estimation. But again, as long as it makes sense, then you're good to go. All right, let's look at the last one, number 6. 4th grade students held a recycling drive. Okay, 4th grade students held a recycling drive. During 1 week, they collected 1,238 water bottles each day. How many water bottles did the 4th graders collect that week? So I want to highlight that they collected 1,238 water bottles each day. There's that hint in there that there's 7 days in a week. And I want to know about, or I'm sorry, not about, how many water bottles did the 4th graders collect that week? So here we're looking at 1,238 times 7. We have that number for each day. That 1,238 is what they collected each day, and then there's 7 days. Okay, so I know that 7 times 8 is 56, and 7 times 30 is 210, and 7 times 200, put my 2 zeros in and my 1 4, and then 7 times 1,000 is 7,000. Just for the sake of having space, I'm going to rewrite that over here. So I have 56, I have 210, I have 1,400 or 1,400, and then I had 7,000. So when I add that up, I get a 6 in my ones column. 5 plus 1 is 6. 4 plus 2 is 6. 7 plus 1 is 8. So there were a total of 8,666 water bottles that were collected. Okay, 4th grade. So that was lesson 11. Great work. You have your lesson 11 quiz today since it's day 5. So just please, please, please make sure you're highlighting, reading the problem, understanding what it's asking you, using area models, using partial products, whatever your choice is. And make sure if there's that word about in there that you're paying attention to that, because then you're estimating. All right, guys, have a great day.